Welcome to Mr. Garofolo's podcast. In today's episode, we're looking at example 8 from our lesson on compound inequalities. In this section of the lesson, we're asked to write a compound inequality when we're given the graph. So as you look at example A, you see that there is a gap between these two graphs, and that's a clear indication that we're dealing with the union of two sets. One of the sets is indicated by this part of the graph, and the other set is indicated by this part. So we look at this part of the graph here. We have an open circle on -3. That's our boundary number. And the shading is going to the left. So this would be all the numbers that are less than -3. So the inequality we could use to represent that would be x is less than -3. Over here, we have a closed circle on our boundary number, which is 5. And we're shading all the numbers greater than 5. So the inequality that would represent that part of the graph would be x is greater than or equal to 5. Now, since both of these are graphed on the same grid, we're going to connect them by using the word or using the union symbol. So we could say x is less than -3, and then the symbol for union greater than or equal, x is greater than or equal to +5. Okay, so what this is the union of two sets. The union of this set here with this set here, and they're displayed as inequalities. In example B, we're looking at the intersection of two sets. How do we know that? Well, you can see that the shading is overlapping each other, and we have two distinct endpoints in the intersection. We have -5 as an endpoint, and we have +2. So as we're looking to the shading, we're shading to the left of +2. So those would be the values that are less than +2. So we would write x is less than +2. The shading is to the right of +5, showing that the values that are greater than -5. So we get a compound inequality that looks like this. And this says that x is greater than -5, but also less than +2 at the same time. Right? This is the intersection of those two sets. It could also be written like this. X is greater than -5, and x is less than 2. These two mean the same thing. We'd like to start getting comfortable writing these compound inequalities, the intersections, using one variable. So we'd prefer to see it like this here. So we take a look at some of the other examples. If you look at C, again, this is the union of two sets. We're going to bring together these two inequalities. So this one will be x is less than or equal to -6. This part is x is greater than 8. And it's the union of those two sets. In D, we have the intersection of two sets. The boundaries are -7 and 0. And x is less than or equal to 0, but greater than or equal to -7. You see the difference between writing the union and the intersection. In F, this is also a union problem because we have a gap in the middle here. We have x is less than 1 or x is greater than 1. This is the union of all the numbers less than 1 and greater than 1. So really this is all real numbers except the number 1. All real numbers except 1. So if we're writing a narrative on this, that would be a nice little narrative to write. In G, this boundary is supposed to be on -8. So we have a boundary of -8, and we have a boundary of +6. We see that it's an open circle on +6, shaded to the left. So that's x is less than 6. But at the same time, x is also greater than or equal to -8. Okay, so by using what you see on the number line, you're able to write a compound inequality using either the union, where you use the word or the symbol for union. And when we have the intersection of two inequalities, we can use a compound inequality sentence like this one here, or in some cases we use the intersection symbol. I would prefer if you try to use the compound inequality like we've written here in B, D, and G, because you're more likely to see that in our class. Well, tonight for homework, you're solving some inequalities, and you'll need to use this in your answer as you graph them. Good luck, and see you in class.